MCV4U1, Chapter 1, Introduction to Limits, Session 12. In this session, we are working on exercises given in Session 11, Exercise 1.5, on page 45, 46, 47 of the textbook. The first question is question 4, Part D. Evaluate each limit. We know to find the limit of a polynomial function, we use direct plug-in. If we plug in 2 pi into the function, we find the limit. Therefore, the limit of x3 plus pi 2x minus 5 pi 3 is 8x3 plus 8 pi 3 plus 2 pi 3 minus 5 pi 3, which is 5 pi 3. Part F, limit of square root of x minus 3 divided by 2x plus 4 as x approaches negative 3. We know this limit is the same as square root of limit of x minus 3 divided by 2x plus 4 as x approaches minus 3. We have a rational function, and this can be calculated by direct plug-in. The limit of x minus 3 over 2x plus 4 as x approaches negative 3 is negative 6 divided by negative 2, which is 2. Therefore, the given limit is square root of 2. Question 7, Part A. Evaluate the limit of each indeterminate quotient. Limit of 4 minus x2 divided by 2 minus x as x approaches 2 is the same as limit of 2 plus x as x approaches 2. 4 minus x2 can be written as 2 minus x times 2 plus x, which is 4. Part C, limit of x3 minus 27 over x minus 3 as x approaches 3 is the same as limit of x2 plus 3x plus 9 as x approaches 3, which is 27. Question 8, Part A. Evaluate the limit by using a change of variable. We assume cube root of x is u. Then the limit can be written as u minus 2 over u3 minus 8 as u approaches 2. u3 minus 8 is u minus 2 times u2 plus 2u plus 4. Therefore, the given limit is limit of 1 over u2 plus 2u plus 4 as u approaches 2, which is 1 over 12. We assumed cube root of u equals x. When x approaches 8, cube root of x approaches 2. Part C, limit of x to the power of 1 over 6 minus 1 divided by x minus 1 as x approaches 1. We assume x to the power of 1 over 6 u. Then the limit can be written as limit of u minus 1 divided by u to the power of 6 minus 1 as u approaches 1. If x to the power of 1 over 6 is u, then x would be u to the power of 6. And as x approaches 1, u approaches 1. u6 minus 1 is u minus 1 times u5 plus u4 plus u3 plus u2 plus u plus 1. Therefore, the limit can be written as limit of 1 over u5 plus u4 plus u3 plus u2 plus u plus 1 as u approaches 1, which is 1 over 6. To break down the denominator, we used this identity an minus bn equals a minus b times an minus 1 plus an minus 2b plus similar terms till we get to b to the power of n minus 1. u6 minus 1 could be broken down as u3 minus 1 times u3 plus 1 and use difference of cubes to break down u3 minus 1. We could write u6 minus 1 equals u2 minus 1 times u4 plus u2 plus 1, difference of squares, and then break down u2 minus 1. Before we do any other question, I want to go over question 8, part A, and do this question using two other methods. Limit of cube root of x minus 2 over x minus 8 as x approaches 8. If we look at x minus 8 carefully, it is difference of cubes, cube root of x to the power of 3 minus 2 to the power of 3. And it can be broken down as cube root of x minus 2 times cube root of x2 plus 2 cube root of x plus 4. And the rest is very straightforward. Reducing the fraction, plug in the number. The other method is rationalizing the numerator. If we multiply cube root of x minus 2 by cube root of x2 plus 2 cube root of x plus 4, we have x minus 8. We reduce it by x minus 8 and plug in 8 into the function. If you look at these two methods and change a variable, we'll see they have the same basis and they are basically have the same nature. By assuming cube root of x equals u, we convert it to a polynomial. By assuming x minus 8 is cube root of x to the power of 3 minus 2 to the power of 3, we can use difference of cubes and factor it. Next question, question number 9, question number 10, part C. Limit of x2 minus x minus 2 divided by absolute value of x minus 2 as x approaches 2. We know x2 minus x minus 2 can be factored as x plus 1 times x minus 2. This is fact number 1. Fact number 2, we know absolute value of x minus 2 when x is greater or equal than 2 is itself, and if x is smaller than 2 is opposite of x minus 2. Therefore, to see if the limit of x2 minus x minus 2 over x minus 2 as x approaches 2 exists or not, we find right side and left side limit. We factor the numerator, and for right side limit, since x minus 2 is greater than 2, absolute value of x minus 2 is x minus 2, and the fraction will be reduced to x plus 1. That means the given limit as x approaches 2 from the right side is the same as limit of x plus 1 as x approaches 2 from the right side, which is 3. When x approaches 2 from the left side, absolute value of x minus 2 is negative x minus 2. By factoring and reducing, we have the given limit as x approaches 2 from the left side equals to limit of negative x plus 1 as x approaches 2 from the left side, which is negative 3. We found right side and left side limit of the given function as x approaches 2. They are not equal, therefore this limit does not exist. Next question, question 11. In this question, a table of values given, the relationship between the temperature and volume, and a couple of questions asked to find. The first part, part A, is asking to show the relationship between V and 2 is linear. To show this, we find the first difference. We'll see the first difference in all cases is 1.6426. Since the first difference is constant, therefore the relationship between T and V is linear. The second part is asking to find a linear equation for V in terms of T. We are looking for the equation of V in terms of T. The slope of the line is delta V over delta T, which is 1.6428 divided by 20. It is 0.08213. Since the V-intercept is 22.4334, the equation would be V equals 0.08213t plus 22.4334. Part D, show the limit of t as v approaches 0 is approximately negative 273. We isolate t in this equation. We solve t, or we write t as a function of v. We bring 22.43 to the left side and divide it by the coefficient of t. T would be v minus 22.4334 divided by 0.08213. As v approaches 0, this limit is negative 22.43 divided by 0.082, which is negative 273.15. There is a note here saying this represents the approximate number of degrees on the Celsius scale for absolute 0 of Kelvin scale. Using this information, graph V versus T. It's a linear function. 22.43 is the V-intercept and the slope is 0.08. Next question. Question 12. Use the properties of limits and show that if limit of f of x as x approaches 5 equals 3, limit of x2 minus 4 divided by f of x as x approaches 5 is 7. We know limit of a fraction is the same as limit of numerator divided by limit of the denominator. Limit of numerator as x approaches 5 is 25 minus 4, which is 21. And limit of f of x as x approaches 5 is 3. So the answer is 21 over 3, which is 7. Question 13, part A. Limit of f of x to the power of 3 as x approaches 4, when limit of f of x as x approaches 4 is 3. This limit would be 3 to the power of 3, which is 27. We know limit of f of x to the power of n as x approaches a is the same as limit of f of x to the power of n. The next part is limit of a division, which is limit of numerator divided by the limit of the denominator. Limit of the numerator is 9 minus 16, and limit of the denominator is 3 plus 4. It's negative 7 divided by 7, negative 1. Part C, limit of a radical and square of the limit are the same. So this limit would be the same as limit of square root of limit of 3f of x minus 2x as x approaches 4. Limit of 3f of x is, as x approaches 4, is 3 times 3, 9, minus limit of 2x, which is 2 times limit of x, which is 6, square root. It is square root of 3. Last question. If limit of f of x over x as x approaches 0 is 1, and limit of g of x as x approaches 0 exists, and is non-zero, then evaluate each limit. Limit of f of x as x approaches 0. We claim this limit equals 0, and our reason is if this limit is not 0, since limit of f of x over x as x approaches 0 exists, we have a contradiction. If this limit is not 0, limit of f of x over x as x approaches 0 does not exist, because numerator is not 0 and the denominator approaches 0. Limit of f of x over g of x as x approaches 0 is the same as limit of f of x over x times x divided by g of x as x approaches 0, the same as limit of f of x over x times limit of x divided by g of x as x approaches 0. Limit of multiplication and multiplication of limits are the same. Limit of f of x over x is 1, and limit of x over g of x as x approaches 0 is 0, since numerator approaches 0 and the denominator is non-zero. Therefore, limit of f of x over g of x as x approaches 0 is 0. Thanks for watching.